Okay guys, this section is a little bit longer and I apologize for that, but we will get through all of it. So chapter 1, section 4, we're going to start talking about reciprocal identities. It's going to start talking about identities in general. An identity is a true equation. So x equals x, that's a true equation. Throughout trig, identities are used to prove that this equals this or to solve equations. So reciprocal identities, just like we did in class with section 3, sine and cosecant are reciprocals of each other. Cosine and secant and tangent and cotangent, those are all reciprocals. So in identity form, sine theta is the same as saying 1 over cosecant theta. Cosecant theta is the same as saying 1 over sine. Cosine is the same as 1 over secant. Secant is the same as 1 over cosine. Tangent, 1 over cotangent, and cotangent is 1 over tangent. So in example 1, we need to find the reciprocal. So as long as these two are definitely reciprocals of each other, this is an easy fix. I need to find cosine given secant is 5/3. Well, secant is 1 over cosine, or we know that they are reciprocals of each other. And as we learned doing the 6 trig functions in section 3, I can say that cosine theta equals 3 over 5. So you can use the identity or you can use your head and say, hey, I just flipped that fraction. Either way works for me. So the next one is sine, given that cosecant is negative square root of 12 over 2. So in this case, when we go to flip this, sine theta equals negative 2 over the square root of 12. We know we can't have that square root on the bottom, so we got to rationalize the denominator. So that's going to give me negative 2 square roots of 12 over 12. 12 is going to become a 6, and that becomes a 1. So you have negative square root of 12 over 6 as your answer. And if you want to reduce that even more, you can, or I will accept that. You can technically reduce the square root of 12. When we talk about the quadrants, we talked about quadrantal angles. So each quadrant, and we're going in a counterclockwise rotation, so quadrant 1, quadrant 2, quadrant 3, and quadrant 4, each function has a positive or negative sign in each of these quadrants. So if you're in quadrant 1, everything is positive, sine, cosine, tangent, and their reciprocals. However, over here in quadrant 2, only sine and cosecant are positive, and that's because your y-axis, you're still in the positive y-axis. Cosine, tangent, secant, and cotangent are negative because they involve this x-axis, which is the negative x-axis. Down in quadrant 3, the only positive functions are tangent and cotangent, and that's because they are y over x and x over y. So your x-axis is negative and so is your y, making that ratio positive. Sine, cosine, secant, and cosecant are still negative because they use either the negative x or the negative y axis. And lastly, in quadrant 4, cosine and secant are positive because we are dealing with the positive x-axis, but sine, tangent, cotangent, and cosecant are negative because they involve the negative y-axis. So determine the signs of non-quadrantal angles. 87 degrees. I'm going to ask myself, well, that's in quadrant 1. So that means that all are positive. All the signs are positive. Okay. 300 degrees, I'm going to ask myself again, well, that's between 270 and 360. So that's in quadrant 4. So in quadrant 4, sine, tangent, cosine, and cosecant are all negative. Cosine and secant are positive. And in this example, negative 200, negative angle, I'm going to have to find its positive. So I'm going to add 360 to that first. And that's going to give me a positive 160 degrees. Now I can say, well, that's in quadrant 2. So in quadrant 2, sine and cosecant are positive, and then all the rest of them are negative. Moving on to example 3. In example 3, it wants you to identify the quadrant of an angle. It's not giving you the angle, but it's telling you that its function is either greater than or less than 0. So it's either positive or negative. So we want to find out what quadrant an angle is in that satisfies both of these conditions. So sine is greater than 0. Where is sine positive? It's positive in quadrant 1 and quadrant 2. Tangent is less than 0. So where is tangent negative? Tangent is negative in quadrant 2 and quadrant 4. So I'm going to look at these and I'm going to say, well, they both have quadrant 2 in common. So the quadrant or quadrants that satisfy the conditions for the angle is quadrant 2. That's my answer. So cosine being less than 0, where is cosine negative? Cosine is negative in quadrant 2 and quadrant 3. And where is secant? It's reciprocal negative. That's also in quadrant 2 and quadrant 3. So in this case, any angle in quadrant 2 or quadrant 3 will satisfy those conditions. Okay. Each function has its own range. So sine and cosine, since they deal with the x and the y axis, and we talk about the unit circle, even though we haven't seen it yet, sine and cosine only have a range, meaning that their values only go between -1 and 1. Now, when it comes to tangent and cotangent, their y values can go on forever. They can go between -infinity and infinity. But then secant and cosecant, the reciprocals of sine and cosine, can only go between -infinity and -1 and between 1 and infinity. So there's a little space that they cannot be. That, in other terms, is just saying the absolute value of either secant or cosecant has to be greater than or equal to 1. So looking at example 4, I want to determine if whether this is in range, is in its range, in each of the trigonometric functions ranges. So it's either going to be possible or impossible. So sine of theta equals 2.5. Well, as we just discussed, sine has to be between -1 and 1. So this is impossible. Tangent, it can range from -infinity all the way to infinity. So this is definitely possible because it's all real numbers. This is between -1 and 1. And it has to stay between that. So impossible, possible. And the last one is secant of 0.6. In order for it to be possible, the absolute value of secant has to be greater than or equal to 1. 0.6 does not meet that condition. So this is impossible. Example 5. Suppose that the angle is in quadrant 2 and sine equals 2/3. I have to find the 5 other trig functions. So if sine equals 2/3 and I'm in quadrant 2, quadrant 2 tells me that my x is negative. So sine's ratio, we know to be y over r. So in that case, y equals 2, r equals 3. And I need to find my x value, and we know it's going to be a negative number. So using the formula from section 3, x squared plus y squared equals r squared, I'm going to plug in what I know. X squared plus 2 squared equals 3 squared. So x squared plus 4 equals 9. I'm going to subtract 4 from both sides. X squared is going to equal 5. And I'm going to take the square root. So remember, anytime you take the square root of a number, you have a chance of it being positive or negative. So plus or minus the square root of 5. In this case, it's telling us that we're in quadrant 2, where x is negative. So in this case, x is going to be negative square root of 5. We then have to find the other 5 trig functions to go along with this. So cosine, which was x over r, will be negative square root of 5 over 3. Tangent, which is y over x, is going to be 2 over the negative square root of 5. And again, we have to rationalize. So 2 square roots, negative 2 square roots of 5 over 5 is your answer there. For cosecant, we're just going to flip. We'll have 3 over 2, because that is the reciprocal of sine. For secant, we can go ahead and flip that cosine. We'll have negative 3 over the square root of 5, and we'll have to rationalize. So that will give me negative 3 square roots of 5 over 5. So negative 3 square roots of 5 over 5. And lastly, cotangent. Flipping this, negative square root of 5 over 2. This will definitely go on a note card. We have the Pythagorean identities. So the 3 main Pythagorean identities are sine squared theta plus cosine squared theta equals 1, tangent squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Now there are alternate forms for these 3 identities. So each one has 2 other ones. So you can also see this written as cosine squared theta equals 1 minus sine squared theta, or sine squared theta equals 1 minus cosine squared theta. For tangent, you can see tangent squared theta equals secant squared theta minus 1, or 1 equals secant squared theta minus tangent squared theta. And then for the third identity, 1 plus cotangent squared theta equals cosecant squared theta, you can see 1 equals cosecant squared theta minus cotangent squared theta, or cotangent squared theta equals cosecant squared theta minus 1. Another group of identities, so far we've talked about reciprocal identities and Pythagorean identities. The last group of identities is the quotient identities. And these only really deal with tangent and cotangent. So your quotient identities, tangent equals sine over cosine. Makes sense because sine represents my y-axis, cosine represents my x-axis. And cotangent, the reciprocal, is just going to be cosine over sine. So in example 6, I need to find the sine and the tangent given that the cosine is negative square root of 3 over 4 and sine theta is greater than 0. So I want to find something that I can plug cosine into that can give me a sine value. That is going to be my Pythagorean identity. So I'm going to use sine squared theta plus cosine squared theta, and that's going to be equal to 1. I know what cosine squared theta is. I'm going to plug that in. So that's negative square root of 3 over 4, and I'm going to square it. And that would be sine squared theta plus that equals 1. Go ahead and square this. I'll have sine squared theta plus 3 over 16 equals 1. I'm going to go ahead and solve, and I'm going to subtract. Sine squared theta is going to equal 13 over 16. Take the square root. And sine theta is going to equal the square root of 13 over 4. So now that I've found sine theta, I can use this information and this information to find tangent theta. So I'm going to use the quotient identity. I'm going to say tangent theta equals sine theta over cosine theta. So tangent theta is going to equal sine theta square root of 13 over 4 divided by cosine theta negative square root of 3 over 4. So I'm going to have something that looks like this. The square root of 13 over 4 times, I'm going to have to flip that bottom fraction. 4 over the square root of 3. My 4's cancel. Be left with the square root of 13 over the square root of 3. And I'm going to have to rationalize the denominator. So I end up with the square root of 39 over 3. And in this case, it is negative because sine theta is greater than 0. So tangent is going to be negative. Well, we have that negative sign that I forgot. So that's actually why it's negative. So negative square root of 39 over 3 is tangent. I hope you guys saw that. We'll put that down there again. So this right here is my tangent value. Last example. Find sine and cosine given that tangent equals 4/3 and theta is in quadrant 3. So, I don't really have anything that ties that I can find sine and cosine just given tangent. In this case, I'm going to have to think outside the box. I'm going to think about sine and cosine's reciprocals. I do have a Pythagorean identity. Tangent squared theta plus 1 equals secant squared theta. I know what tangent is, so I can plug that in. 4/3 squared plus 1 equals secant squared theta. This will then be 16/9 plus 1 equaling secant squared. 16/9 plus 1, make this 9/9. That becomes 25/9. It's great to work with fractions with trig. Don't be changing things to decimals. Equals secant squared theta. I'm going to take the square root of both sides, and I'll end up with 5/3 equaling secant theta. Now, theta is in quadrant 3, and secant is negative in quadrant 3. So we had that chance of it being positive or negative because we took the square root. So secant theta is going to equal -5/3. But I don't need secant theta. I need cosine. So remember, cosine is a reciprocal, so cosine is going to equal -3/5. So now I have a cosine value and a tangent value. I can go ahead and find sine. I'm going to use that alternate form of sine squared plus cosine squared equals 1. So sine squared theta is going to equal 1 minus cosine squared theta. Sine squared theta is going to equal 1 minus -3/5 squared. So we'll have 1 plus, oh, my bad. That'll make this a positive. So 1 minus 9/25. And when we do that, we're going to have 16/25. And that's still going to equal sine squared theta. So I'm going to take the square root of both sides. Sine theta is going to equal plus or minus 4/5. And since we are in quadrant 3, sine is negative in quadrant 3, so sine theta is going to equal -4/5. Your homework is listed on the agenda for this section, so go ahead and work on that. Thursday, you'll work on a review at home. For those of you at home, in class, you'll be working on the review in class. And Friday, there will be a test on Schoology. The window is going to be between 10 and 12. If you need to talk to me about that, let me know ahead of time, not the day of the test, like on Thursday. And if you have any questions, guys, I know this was a long section. We will get through it in class, so we will not be behind. Just go ahead and let me know if you have any questions. I know there's a lot. There's not that many of these questions on your test, so it's more of a work in progress. This is just an introduction to this.